Alright, let's get it. Oh, it's too loud. Such a loud fucking song. Okay, had to add constant and constant expression to this program that the user inputs a height and we call. I'd rather just do a loop for however many seconds we want, but fuck it. It just has 5 different calls with the number. Yeah, it's stupid. I don't know, this is a stupid implementation. But the user enters a number and then it calculates how far the person has, or the ball has fallen, and then prints that height. And I'm trying to make as many things constant in constant expression as possible. So we get the tower height from the user. We have where the ball is now. We have printing of the ball height. Excuse me. And we have a helper function that calls those other bits, that calculates the ball height and prints it. Because we want functions to have one purpose each. So we might have a get the height or calculate the height, print the height, and then we might have a function called print and calculate the height that we call that does it. That way, all we have to do is print and calculate the height. That's it. And really before it, we can get the tower height too, but instead of doing a loop and getting the height once and then whatever, we may as well just get this once. I would still rather do a loop here and then just have for I inclusive through 5. Do this and then just pass it I in tower height, so it looks like 2 lines instead of fucking 6 here, but whatever. So tower height should be constant because once we get it, it shouldn't change. We can't make anything else in there constant because we have to update tower height. Okay, that's next. For calculate ball height, this can be constant expression. Why? Because we're passing it values, so it's fine. It can be constant expression. Well, hold on here. This can't be constant expression because these must be done at runtime. But calculate ball height doesn't necessarily have to be done at runtime. If distance fallen or current height happen to be known already, then we're good. In this case, current height is determined by tower height, and distance fallen is determined by the number of seconds. Why can't this be constant expression? What calculates calculate ball height? This. We're passing it a runtime only value. But seconds is known at compile time. I'm not sure why this... Really? Why? I mean, seconds is the only thing here. Oh, it's because, well... I'm not sure yet. Ooh. I'm not sure yet why this can't be constant expression. The function is fine being called constant expression. Gravity's good. I mean, I get current height because tower height isn't known at compile time. But seconds, though. shouldn't distance fallen be known at compile time though? Because if we had 0 seconds, well, there is no 0 seconds. Seconds are just what they are. This depends on tower height, so this guy can't be a const expression because tower height isn't known at compile time. It's only obtained here. I'm really not sure why distance fallen can't be. I mean, gravity is. Seconds should be. We're calling this is a constant into seconds. Oh. Oh, duh, that's why. We can't use parameters to initialize const expression values. So if we look at any const expression value we have inside a const expression or inside a function, the only one is gravity, and it's because this does not use anything that's not const expression. This uses seconds. Seconds is a parameter. It's not required to be const expression. It's not required to be known at compile time. And to initialize it, this must use stuff that must be evaluatable at compile time. So we can't. We could replace this to be, we could update this guy to be a, we could have a template here. Well, but then we have to change things around. I don't know how that would work. No, it wouldn't work very well. Because if we call this guy and we did a template, well, it would get some value. It can't be const expression because it doesn't return a const expression value in at least one. Hold on. Yeah. Yeah, it isn't returning it in at least one case. We don't want to have to manually call calculate ball height from here every time, so we can't. Oh, hold on. I don't know how that would work for the template part. I think the template part needs a literal. So if we do a non-type template parameter, or argument in this case, I would have to give it a literal. It needs to be a const expression value. So if I pass this like normal here, and then we just call calculate ball height, and then we just use tower height and then in parentheses, but in between we have a little guy here and we put in seconds, that won't work because this guy's not const expression, so we get the same issue. So we either have to explicitly call this with the literal, or somehow make a literal out of something. So like we, yeah, I think we just walk into the same issue. Basically, if I have a const expression value and I want to pass that as the non-type template parameter or argument, then it is to be made from a constant expression. But the parameter that we send, seconds, is not a const expression because it can't be a const expression as a parameter. Can't be const expression because of tower height. Can't be const because it has to change and update. Can be const expression because it can be ran at runtime or not, and it can return. Well, C++ isn't as, it doesn't put the functions in as much scrutiny as the variables do, as the variables are. So it's harder to make a variable a const expression than a function. The function we just kind of made as well. But for ball height, this won't work because we're using it's not calling anything. Cool. All right. This guy here, however, well, because it isn't returning anything. I'm curious, why is it because this is calling, or no, this isn't even calling a function to do that. I'm not sure why this can't be. It can. Am I just stupid? I guess so. Yeah, it's good. Okay. But const eval, we need tower height in here, so not everything. So like if we did, oh, here we go. This is cooked. Yeah. The call to calculate ball height, or hold on. The call to the immediate function. Oh, well, this is the immediate function. It's not a const expression. Const eval functions are more picky. These have to be, oh yeah, duh. Const eval functions, the arguments or the parameters must be const expressions, and double tower height is not. So we have to leave it const expression. It's like the less picky version of a const eval. We can do a const expression print ball height, so we can see if the compiler wants. Well, the compiler's never gonna do it actually at compile time, because it's not gonna have ball height until print calculated ball height is. Well, hold on. If this does print calculated ball height, and we calculate ball height, yeah, calculate ball height. Tower height isn't known until runtime. So it could, I mean, I guess it could if we change tower height to be known at compile time, but it's not. So it's fine. I mean, it's not going to do anything, but okay. Print ball height. Or yeah, well, same shit for ball height here. This is only going to happen at compile time if this is known at compile time, which it isn't. So this isn't actually going to be done at compile time. Is there even any value here? I mean, maybe it's optimized into a certain way. I mean, maybe it's inline expanded or something, but so inline expansion meaning print ball height right here. Instead, it might just copy this code and replace it here, which, I mean, could be fine. But, I mean, technically we could just do that, right? Like that. It's the same shit, it's just inline expansion. It's taking this code and putting it here. That way we don't have to fucking... What would we do here? That way we don't have to pass seconds or ball height, but I mean, seconds and ball height are just integer and double, so it's not like they're important or expensive. Anything else? If it was created in a const expression function, we'd be okay, but we're not. I mean, you could say You call print ball height once, and then the loop is here. And in the loop, it does this, and then that, and this, and that, and then this, and that. Those 6 times in this case for 0 through 5 seconds. And you could have seconds be a const expression int created in here, and you pass it, or it's just in there, and then I think would be okay. Okay. Let's see what else you got, huh? I mean, we don't want to change tower heights. I mean, I don't have any issues of making it const. Should not be made const expression because output and well, I mean, we know right now, at least with this use case, that we're not going to fuck with tower height. Tower height is the tower height. Sure, we're subtracting something from tower height to get the fallen height. Because if we start at this, or to get the actual height, because if we start at 100 meters up and then we fall in 40, we subtract 40 from 100 to get, oh, we're at 60 meters above the ground right now, or above whatever's below the tower. So I think making that like this is fine. It doesn't do anything here. It evaluated. In this case, it's called at runtime. Yes, exactly, because tower height. Yep. If it can, it should be. Makes sense. Gravity, because, yeah, we know it's compile time. Yep, exactly. And then const for distance fallen and height, which we also don't want to fuck with, so I would support making this const. Yeah, I guess that's true. If it can only be done at runtime, then it shouldn't be made const expression. I mean, I guess that's true, right? So if we say, hey, we can only get ball height, or hold on, how is this working here? In order for it to have tower height, it can only be called at runtime. Is that the point here? So we don't make these const expression because tower height isn't known until runtime. Yeah, and these, yep, makes sense. Same shit. And height is only const. Why? Because tower height is not a const expression. It's only known at runtime. Cool. I mean, same shit. I just accidentally made 2 void functions const expression when they technically shouldn't be. I mean, it really doesn't matter. But I think the best practice was to only make them const expression if they can at least in some circumstance be used at fucking compile time. And of course, yeah, by clicking into a fucking video for like 20 seconds, I had to chop up the YouTube videos. I mean, thankfully YouTube does it automatically, so there's just gonna be 2 little jump cuts. Or 3, one in one video, 2 in another. I'm gonna do some push-ups real quick. This counts as work, it's refreshing the brain. And now I get to learn complex types. I don't feel burned out either, so. We'll do, I don't know. Let's try 3. This is gonna be hard. Okay. Just negatives. I don't remember if it's 2 or 3. I don't know what's popping, if it's my back or what. Okay. Something like that. What are we gonna see? Where is it at? We don't even have it yet. Hello? Oh. And so these are references to stored stuff versus references to, like references to unnamed things versus named things. So objects versus variables, it seems like. Okay. Yeah. Because right now I want to make a copy of Liar's Bar as a game because it just sounds fun. I want to play it. But I don't have anybody to play it with, so I'm going to make it. I was thinking about it on the plane, the last flight that I was on, or one of them. But I need a way of storing like a character's hand. That way I can tie the character with like it's probably doable with a whole shitload of different variables, but like player 1 and then player 1 card 1, card 2, card 3, card 4, card 5 and then like player 1 gun and then the separate bullets. These could be objects within objects. So there are actual objects called the player, and each player has cards, has a hand, which has 5 cards, or up to 5 cards, and has, oh, and we could destroy the objects too. And has a gun, and the gun has bullets, or rather it has chambers, and they either have a bullet or not. Or we could just say shots. And we say that there's a random chance for each one, a switch case maybe. The thing is, if I have a function called round, or just a function called play game, and we start the game, and then it outputs what one player does, and, or I guess we do like a random roll to see when you go in the turn. Let's just assume you go first. And you have to start by playing cards because you went first. The first you'll play cards. Oh, we can have a do while loop for you to play cards. And the while is while the condition is if you've chosen appropriate cards, something like that. After you've done cards, the enemy or the other guys, the enemies will, or the other players will play their cards and use a random number generator, a pseudo random number generator to decide which cards to do. But there are different combinations they could do. But I need to track what cards they actually have. And each card is what? Maybe a standard string, or maybe I have numbers that correspond to each one. So we just say that I could do a type alias for standard string and just make it card. Type def standard string as card, or using card as standard string. But I'm gonna have to pass around standard strings. So maybe we have standard string views. And we have a Mersenne twister that gives each person cards. So we could say we could call a function for deal cards, which gives 5 random cards to each person. But after you shoot the bullet, or after you shoot your gun, and you get a 1 in 6 chance, and you stay alive, or if you die, I guess I decided not to do it because of just how many variables would be needed. Because I would need a separate variable for player 1, 2, 3, and 4 alive. So is player 1 alive? Is player 2 alive? Is player 3 alive? Is player 4 alive? That way, for the start game or the turn function, void turn probably. And maybe int turn because it says how many turns. Or no. Int turn, void turn probably. And then it only triggers the player's turn, or it only triggers the logic for this player if they're alive. But then we have variables to track who the player shoots. Or no, because the player doesn't shoot anybody, duh. It's just that the person who got called has to shoot. And so what happens, we have a revolver, and we have a switch case and a random number, and we get a random number from 1 to 6. If it's 6, you die. If it's 1 through 5, you don't. But after we trigger 1 through 5, I guess we don't have fall through. I was thinking we'd have fall through where 5 cases would say click and then 1 would be bang. But actually we need click, or we need if, hold on. We don't want to go to, I guess, but oh wait, can't I do, no. So I want it to be 5 clicks and then bang. And let's say we roll 5. I need to update the numbers so that it can't roll 5 again. Maybe for each player we have a variable that is the numbers to not roll or something. It seems like it's just getting convoluted. Because now I have to restrict the range of the random number that we can roll. Because if you shoot once, it's an 18% chance to die. But then after, you've only got 5, so it's a 20% chance. Maybe it's 16. 6 times 6, 36, plus 60. Yeah, it is 16 actually, sorry. 16.8 or something. 16% chance. We roll 5. But now we need to update the dice roll. We leave the switch case, but now you just can't roll 5 again. So what do? We have to update the range. Oh, I guess that's what we say. If click, then we update, we reseed the standard uniform int distribution to now only roll for this player for hit. So there's a standard uniform int distribution for each player. Or we just update the same one, so there's 1. And it's like we have a gun and it's loaded with 6, and you can roll any of the 6 and then whatever. But then afterwards, we need to store it for each person. So maybe that's what we would do. We have a standard uniform int distribution for each player. So player 1, after he rolled 5, he can't do 5 anymore. So it's from I mean, I could have 5 dummy bullet variables, and we say roll the dice until it's one of the appropriate numbers. And if you haven't shot yet, it's while it's not 0 or 0 or 0 or 0 or 0 or 0. But yeah, I guess so. Yeah, if it's so we get the roll, and if it's not this, proceed. Otherwise, roll. So while it is not this, then we go. So like basically shoot, roll the dice, and as long as it's not the blank that you've already shot, then go again. So if you've shot 3 times, let's say you rolled 2, 3, and 4, so you have 1 and 5 and 6. 6 is bang, 1 and 5 are click, click. Excuse me, we can update the rolled dice to be do roll, and then while the roll result is not 2, 3, or 4, proceed. So if you get 1, we go to the switch case, click, and then we update it to be, we update the blank roll result 1 to be whatever 0 instead of true, or something like this. So it's not 1. So now it's checking to make sure it's not 1. Because at first it's checking if it's not 0, but then it's checking to make sure it's not 1, and then it's checking to make sure it's not 1 and 3, and it's not 1 and 2 and 3, or 1, 2, 3, and 4, and then not this. But it's first, it's saying is not 0, 0, 0, 0, 0. If it's 6, or hold on. Yeah, and it's never going to be 0, so you can roll 1 through 6. And if you roll 3, then next time it's going to be checking not 3, or not 0, 0, 3, 0, 0, and that's it. 0, 0, 3, 0, 0. Because if it's bang, you just die anyway. If you ever roll this, then you're done. So we only need to account for the blanks. And then if you roll 1, it's checking not 1, 0, 3, 0, 0. Okay, so if it's 2, 4, 5, or 6, that's fine. And then it checks for not 1, 2, 3. So 4, 5, 6 work. And then not 1, 2, 3, or sorry, not 1, 2, 3, 0, 0, 6. So if it's 4, 5, or 6, we're good. And then, yeah, so I think we could do that. It's just so many fucking separate variables. I'd rather have them all stored within one thing. There'd just be so many. And I guess I'd have a namespace for each one. So like player 1, player 2, player 3, player 4, bullet 1, bullet 2, bullet 3, bullet 4, bullet 5, bullet 6, or something like that. And then the int distribution for the gun, and then all this stuff. Yeah, something like that. That way when you play, you choose which cards you're going to play. It says you have these cards. Which cards are you going to do? But then I have to have a way of storing the cards properly. So that it says, hey, you have these cards left, and it removes the ones that you've used. Maybe it's multiple choice. Okay. Let's see how that game's even doing. I'm just curious. Oh, pretty good. Okay, we have fundamental types. They don't cover the rest of the needs. Okay. Writing a math program to multiply two fractions. Okay, so we have number 1 denominator, numerator 1, denominator 1, numerator 2, denominator 2. What? Oh, the point is I do 3-4, and so the point is, yeah, exactly, there it is. I didn't read that. Yeah, so we eat the slash 3-4, and we extract that, and we extract 4, 3-4, and then 2-4, and then we multiply num1 times num2, and then denom1 times denom2, and then we output it as whatever. Let's say it's 1/4 times 2/3. Well, 1 times 2 is 2, and then whatever I said, a fourth and a third, so whatever it is, 2/12s, so a sixth, something like that. Or a half times 3/4, so we get 3/8. Cool. And it's only loosely linked, meaning we have all these separate little variables instead of having like player one, or like player one dot num1, or fraction one dot num1, fraction one dot denominator one, and then another. So we have two things that have pieces of information about them. Makes sense, yeah, because variables are independent. We don't have anything that they're children of or a piece of. There's no whole. They're just separate things. Just like for my thing, we just have separate variables in namespaces, and I'm basically using the namespace as the object. If I didn't have a namespace, I'd have a bunch of shit in global scope, or I guess I'd have it in the play game scope as the local variable. But I'd have so many local variables, and they would all have their own names instead of using the same name for different namespace names. Player 1 bullet 2, player 3 bullet 2, player 1 : bullet 2, etc. Oh, gotcha too. I mean, you could have a function that updates it, so you could have a namespace for fraction 1, another one for fraction 2, and then the first thing is extracted to the namespaces, whatever, and then this. So you're just updating the specific ones. So you're saying, hey, update num1 to be this, and num2 to be this, and then whatever. Yeah, instead of doing standard character input like this. Yeah, we just do get fraction. And the get fraction is a void function, but it extracts input to variables within namespaces stored elsewhere, because fraction functions can only return one value. Oh, that would be cool. If we could have an object that was a fraction, and it has two numbers in it, and I extract info to one and extract info to the other part, but then return the object itself with those two numbers included in its data, that would be fucking sick. Keeping a list of IDs, ID1, ID2, ID3. Yeah, 100 different variables. I mean, this isn't. I mean, we could do some bit set shit, but no, but then the IDs aren't unique. So, what would we have? I mean, we could have a static local variable that we. Or hold on, what would we have? We'd have a. Yeah, we could increment it each time. Oh shit, the mic's actually kind of small. I didn't know that. Forgot. So we could use a Merson Twister, but then we could get the same one. So I guess we would just have an ID 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. And then, because I don't know a way to check for duplicates. So I would just have a static local variable or a global variable, and then we get it and increment it. That way we can just get whatever the next ID is. But how do we store them? Do we store them as separate things, or do we just have a an object called IDs and then, yeah, I don't know really. Oh fuck, if I have to pass all of them and then sort them? I don't know. I mean, we had arrays back in, fuck, how did we do that? I remember doing bubble sort, where we have an array, a bunch of little elements, each a number, and we flip if the first is less than the second, or if is greater than the second, we flip them, and then we go to the next, and then if those two, and we flip, and then we go through and flip over and over again, and it was the easiest implementation to do, so I did that one to eventually get something sorted. Because if it was 3, 1, 2, 3 and 1 would be flipped, but then 3 and 2 would need to be flipped, so they would be flipped, and then etc. And then if this was 50 here, well, every time 50 would constantly be getting flipped until it finally gets where it needs to go. Not very efficient, though. I think that was like a big O of X, maybe. So like for every new data point we add, that's another iteration it has to do, which is terrible. Yeah, I mean, because when we did that, I think we also had one in multiple different arrays, and I could set an array to be equal to another array to copy all the elements from one to another. And then I could update the first one, and I could have a formula to say, hey, this index and this index, I have like an intermediate index, and it says, okay, hey, here's 1 and 2. This little intermediate guy gets 1, and then we set 1 to be 2, and then I set 2 to be the intermediate guy to swap them. And then we do that for each thing. And then we have the pre-sorted and post-sorted guy. Compound data types. It's either fundamental, so like a single, or a compound, defined by using multiple others. And a function is the compound type because it's defined in terms of other existing types, or it's defined in terms of fundamental types. So a function, in its definition, includes parameters, and it has its other data types because functions can take data types. If we say that void is a fundamental data type, then yeah, by definition, functions include a data type by default. At least one void parameter, seems like. It's just unnamed, temporary, probably. C-style array instead of a standard array, I guess. Functions, pointers, references to specific places of memory, whatever the fuck an enum is, and then classes. Never heard of a union. I think classes are just structs with more stuff. Constructors and destructors and properties, public, private, member functions. Oh, maybe structs don't have functions. That could be it too. Yeah, the type is void and double. Makes sense. Oh, meaning the type of the function is defined by its return type and parameter types. So I wonder what type a template function is that returns a standard string No, I guess the template part is just to explicitly. I don't really know why the template part is there. Well, I guess it's there to say that, hey, these are template things. So like so what? Standard string and then template shit for integer and then integer, something like that. Or integer and then integer boolean. Wash my hands. They got kind of clammy after the push-ups, I think. Okay. I'm gonna need to cook chicken at some point. So maybe I have a longer break after this one. Maybe I take an hour and I cook chicken. Make a chicken salad or finish my spaghetti. I want to check if this ginger dressing is any good or if I have to use balsamic. So like if I had a template with a non-type template parameter, like int x like this, and then we had standard string returning standard string that takes an int that, what would this look like? I'm trying to make the explicit specialization. Alright, I guess I wouldn't need this then, huh? So I could say int like that. So I could have a and honestly it doesn't, this doesn't even matter, but we could do, yeah, so we pass it the number of moons, the number of citizens, so 7, whatever. We'll just say 7e. Well, do we even... Wait. Oh shit, hold on. Oh, yeah, because string includes some parts of the standard library, so we can do it. So we can do int64 t. That. So we could do, what is it? We're going on 8 billion, so 8e9, is it? Hundreds, thousands, millions, billions. Oh, fuck, is it to the 12? Really? 8, right? So that's thousands, millions. Oh, that's just billions, right? Hundreds, thousands. No, that's millions. Hold on. Hundreds, thousands, millions, billions. Okay, never mind, never mind. Yeah, it's $1,000,000. It's 8 billion. Okay, never mind. E9. Okay. Oh, oops. We need like that. There we go. And then, what's the type of? Isn't there a name for the type of planet that Earth is? Oh, I'm just gonna say watery. What happens here? What's happening? Oh, because this is scientific notation. Fine. 8,000, 8,000,000, 8,000,000,000. What's happening again? This is a standard string. Oh, this isn't. It's being passed the wrong thing. Passing a standard string. I was passing it an array of const character, or a pointer to const characters. Never fucking mind. Oh, I'm not ending the call. Hello? Well, whatever. Say. It doesn't matter. Well, it's not using oh, but yeah, I forgot. It doesn't care about standard strings, so. Oh yeah, it wasn't returning anything. Hello? Oh, well, I guess we could just return it as a standard string. Like that. And we initialize it with the C-style string. And I can initialize this one with the C-style string as well. Like that. And so the type of this would be standard string. Right? Isn't it int 64t standard string? I think that's the type of this guy. Or maybe not. Maybe it's template int x, that kind of thing. Maybe that's the signature. I'm not sure. Okay. Well, can't I just call and check? Yeah, it returns a standard string and it has an int in there as a non-type template parameter, and then an int64t and a standard string. Okay, I think that works. Yeah, functions are extra too, but they do involve multiple different data types. Or they involve other data types that exist. Fundamental data types. Multiple chapters. Okay. lvalues and pointers. Oh my god, I get pointers now. Holy shit. Enums. Next chapter? The whole chapter? We cover enums and structs. And then we do classes and array stuff, including what the fuck a standard string is. Which is a class. Well, it makes sense because in the standard library is some sort of object, which is the string. But it's a type of a class. A class type is a type that is a struct, class, or union. Because those are the types of classes. So a class type is a class. A class is a class type. Structs in a union. I don't know what a union is, but all right. L values and R values. It feels like I leveled up and I'm in scary territory right now. Really. Let me get water. Okay. 34 more minutes until 4.5 hours of learning done. And then what do I do for the rest? I don't know. I think maybe a longer break and then test stuff afterwards. So at 4:30, I don't know, what do I take, like an hour break or an hour and a half until 6? And then at 6 we do a 4-hour thing, so it's another hour and a half, and then and then hour and a half, and then half an hour, and then an hour and a half, and then whatever I want for the rest of the day, maybe. And that's 7 hours. And it would be 3 hours of testing and reviewing. Yeah, I think so. That works. Yeah, because in an hour and a half yesterday, I barely got fucking anything done in the test. I didn't even finish it. Right? Maybe it was only an hour. I don't remember. An L value reference? The fuck is an L value? A literal value? Mm-hmm. Yep. And this is also an expression where we're evaluating this to be standard character output, which does something. And the side effect here is that this outputs text to the console, or to the terminal. Well, console, same thing, I guess. So, like if we do this, sure, it evaluates to x, but that's after incrementing it. I mean, it seems like that's what it's doing right there. It's evaluating to be standard character output, no? A type and a value category. The expression has a type and a value category? Really? The type is equivalent to the type that results. Okay, so like type of this guy is an integer. The type of this guy is, I think, an O stream. Yeah, so 12 and 4, this is an integer expression, double expression, because the common type, implicit conversion, and then auto becomes type double. Oh, meaning that matching types, meaning that the conversion happens first before the matching type. These already match. This is converted to 4.0, double. Yep. If it's valid, meaning if we're printing foo, we're passing a bunch of characters, a C-style string, to be implicitly converted to be an integer, and maybe there's no way to do that, so it errors. Yeah. So the type has to be determinable at compile time. What is this going to be? That way we can determine whether it's appropriate to use it in calls to something else or in operations with something else. So if we say is quote hello quote greater than 3, I'm not sure. I think it always evaluates to true C-style strings in conditions. So I'm not sure if it's able to be implicitly converted to either true or false or what. But if I assume true, then we're going to get 1. Or it just can't convert. I don't know. It seems like it maybe can't convert if it's already having trouble converting to an integer here. Oh, this fucking hurts. So the expression type is figured out at compile time, but the value can be found later, maybe. Otherwise, we would get runtime errors, right? We can't assign x to 5. What would it mean to do that? I don't know. Does it mean we would assign the literal or the value held by x to the piece of memory where 5 is? Is 5 in memory? 5 isn't an object as far as I can tell. So it has ways of determining the category, the type of the function. Well, hold on. Different. Type and value category are different. 5 is an integer. This has an integer, or and x has an integer value where it is in memory, so why can't they be assigned to each other? Because of the value category of the operation. Seems like there are different types of values. Okay. An L value. A left value or locator value? It seems like it's, yeah, okay, that makes sense. Versus R maybe being by the literal, rational or something, or... And so the point is the right operand there, X. We can't assign an L value to some other type of value, maybe. Maybe an R value. An L value to an R value. An entity with an identity, meaning with an identifier, seems like, can be differentiated from other similar entities. Meaning that I can look at the bucket and see what type of thing it holds. Seems like... Yeah. Hmm. Makes sense, yeah, because we can usually refer to them, but maybe there are cases like a class that's created and destroyed in the same statement, in the same, if that's even possible. And usually they would probably last longer. So like X is created, well, it's fucking persisting past that statement, so it is an identity. It is an identity holding entity. An entity with an identity. An entity with an identity. Entity Okay. X is an L value expression because we are using maybe only L values. That is values within objects, or that we're using objects as operands. Or the what is it, value category is determined by the one it evaluates to, and in this case the expression x itself. X is an L value expression that evaluates to variable x, which is an entity with an identifier, or an identity. Modifiable L values and non-modifiable ones. Like a literal maybe? Or are we just saying const something? So x is a modifiable L value because it's non-const, whereas d is non-modifiable. And R value is an expression that is not an L value. So instead of evaluating to an object, it evaluates to a value itself, so like 5 or 7 or whatever. Commonly seen are literals, except C style string literals, because for some reason I guess that's because those are characters. Even though the literals, they're actually characters that are stored somewhere. And the returned value, yeah, so temporary objects, maybe? Yeah. They have to be used immediately and only exist in the scope of the expression in which they're used. Meaning, when we call get int and it returns a number, it returns 5, that 5 is only usable where it is being passed to something and used to assign something. Then it's just gone and we can't get it again, seems like. It to be used immediately and only exist in the scope of the expression in which they're used. The expression itself. So it's only in scope literally from 5. That's it. This simply returns 5. Int x is 5. It's an R value expression because the value we're assigning is 5. Same with 1.2. But if we're assigning x or e, then those are L values. Oh, well, one is modifiable, one is non-modifiable, and then is this an R value? Yeah. Because return 5 returns an R value. And then we have that plus 1, but isn't it still evaluating to... Really? X plus 1, because it includes an R value at all? And then static casting... Oh, so I guess... if we aren't using literally just one... or well, if we're saying like W plus X... is that a return type thing? With some sort of hidden add operation or function? Making it an R value? Or is it simply... I don't know. Well, I guess it would be an R value because there's nothing that points to where it is. W plus whatever. So X plus 1, the value isn't anywhere. So it's R value. Static casting D, which is a double, 1.2, a const double to an int, is returned by something. It isn't stored anywhere. And it's because x plus 1, if we don't do anything with it, it's just an expression statement. So it's not an identifiable object. Like return 5 is 5, static casting D to an N. If we don't do anything with it, it's gone. Then return 5 is gone, x plus 1 is gone. L value expressions evaluate to an identifiable object. An identifiable object, R value evaluates to a value. Because if we say Y evaluates to the object Y, which is identifiable and located somewhere in memory. But if we say Y plus 1, that's the value of Y plus another thing. We get a value in the end, not something that's somewhere. I'm fucking learning, dude. I'm getting tired. Operators expect their operands to be R values. But what if we do the L values though? Like we pass in x plus 3. These are operators in general. Why that and that? Assignment operator requires the left operand to be a modifiable L value expression, meaning that we can only assign some value, something, to an object, a modifiable object somewhere in memory. Five is an R variable, not a modifiable L value. Okay. But we can convert from L value to R value, right? Because if we say that x is y, we're assigning y to x. Well, we're converting y to be some R value, which is then assigned to the L value on the left. But in the second case, line 7, 5 is not a modifiable L value, it's actually an R value. Okay, the L value will go at L value to R value conversion. L value is evaluated to produce its value. L values get implicitly converted, but R values will not just be stored somewhere in memory. They're not going to be converted like that. Yeah, we're not going to say that, oh, hey, 5 is an R value. We're assigning something to 5. That means that 5 gets converted to be an L value and is put in memory somewhere and named somehow. Nah, buddy. So if we say X and we're assigning it to, we have an R value, we're assigning to an L value. But then we're evaluating X and L value on the right, adding it to an R value, and we're getting an R value, and then we're assigning an R value to a modifiable L value. On the left, it's an L value. On the right, it's an R value. Well, it's an L value converted to an R value. Yep. Is the result of operator plus plus an L value or an R value? Well, depends on how it's used, it seems like. I mean, couldn't we say plus plus x is assigned 4? But then there's the question. I think it increments it and then assigns it. So you could say that plus plus x, or what is the result of plus plus x that? I mean, seems like it's a. And I guess it would just be the x, right? Because it's not being used for something else afterwards. Or would it be an r value actually because we're incrementing the r value? Oh, okay. So if we're incrementing x, I think. Ow! Dick was hurting for a sec. If we're incrementing x, aren't we still just evaluating to be the identifier, the identifiable variable x? I think so. I think that's an L value. P R values and X values? Oh, really? IOStream and string? is underscore L value. Oh shit. So if this is the fuck? The reference to this type is an L value reference because we're referring to something that is of a particular type, but it's a reference to where that is in memory. But if we do another reference, then we're referencing the value of it, maybe? Or it's just a literal value, something like that. Print vcat. Value category, okay. Pass it some sort of expression. And inside it, it outputs hashtag expression. So maybe the expression is, and so we pass it 5. 5 is an, is that expression an L value? If yes, an L value, otherwise an R value. So we do 5. Oh shit, they depend if we're incrementing. They depend on the type. Okay. 5 is an R value. Get int. When we call get int, it returns 5. It's an R value as well. It's a temporary little value. We have x. X evaluates to, well, hold on. Yeah, we have x. And we're evaluating x. X is some named thing somewhere in memory there. A standard string. Same thing because it's temporary. It's an R value as well. Hello is a C style string, so I guess that's an L value because these are characters. If we are incrementing x, the prefix, it's an R value, and it gets us 6. Oh, no, it's an L value. So if we increment it first... Oh, well, I guess true, huh? So it... Interesting. Plus plus x is an L value. So we increment it and evaluate it. So if it evaluates to the post incremented guy, it's evaluating to whatever x is. But if it's evaluating to the pre-incremented guy, then that plus plus is adding 1 to the value that's there, which evaluates to 6. Instead of 6 as a value, not 6 from it. So the top evaluates to x, the bottom evaluates to 6. Oh my god. Oh. Oh. Alright, I'm gonna say 6-hour or 2-hour break, I think, is the strat. Then at 6:30 I can do another 2 of those. Or another like 1, and then we got 2, and then so that's 6:30. So 2 hours. I finish up a rest at 8:30, and then go an hour and a half until 10. And then at 10 I can do whatever till bedtime. Okay. Oh fuck. Excuse me. Okay. Okay. Alright, time to upload.